Okay, so we just have a few minutes for some questions. We've gotten a couple, and so, for example, and again, this is like for I guess for current speakers is right. You know, is it necessary to have like a perfect simulant that mimics 100% of the characteristics of lunar dust, or you know, are there ones that can be used with just existing simulants, or do we really need to have like, you know, how much fidelity do we need? Okay, can people hear me? Sorry.
Yes, we can hear you.
The audio broke. Okay, sorry, the audio broke up. Yeah, so
fine.
the question is, yeah, so how much fidelity do we need? I guess it's if, you know, I don't know, maybe Joel or Ryan and Addie.
Talk about in terms of simulants?
Yeah.
Yeah, I mean, simulants they're a tough beast because, you know, you can have one that really represents the geotechnical properties like really well, but maybe it lacks on some of the things like, you know, the compositional properties or the magnetic properties, or vice versa. You can have one that's a better compositional simulant, but not a good physical simulant. So I think it really just depends on the question you're trying to answer. If it's something like trafficability or you know, dust sticking to things, you may want to focus more on the physical aspects. Yeah, I mean, that's kind of a hard question.
Yeah.
I'm not a simulants person, but I think it really just depends on the question you're trying to answer, and whether you prefer more perfect physically or more perfect compositionally, you know, knowing that no simulant is obviously perfect.
Yeah. Okay, and then another question is, right, you know, there's been a lot of work over the last 50 years, right, since the Apollo missions in terms of understanding dust, right, and so is, right, you know, are there things that we're missing, right? So
yeah, I mean,
you know, is there anything that we've learned? Yeah, go ahead, Annie.
Yeah, one comment I would make on that is obviously, like for these workshops, a lot of what we're trying to figure out is what are the open questions. So there is a lot of work, right, that's been done in dust mitigation, and in even in like dust tolerance and things like that over since Apollo, during Apollo and since Apollo, and there are a ton of really useful reports on those things. So I think that we tried to emphasize some of the open questions just to understand how we can continue to move forward, right, building on what we already know. I don't think that I think that there's an acknowledgement of the work that has been done in those areas.
Great, thank you.
That being said, if we've missed stuff, please.
Right, and that's the point where we're having, yeah, and that's the point where we're having these types of workshops. And so we're getting back to the question about simulants, right? We do have some folks who participate with the Lunar Simulant Project, and I just added the link for you know, to access the simulant page on the LSIC page, you know, and people can, we have a survey that people can add in terms of like what kind of simulants, what are their needs, right? And so we hope that folks who are, you know, needs for simulants, and especially if you need, you know, there's different types of needs or requirements to fill those out. Okay, and then I guess the last one here is for Nikki. Are there any CLIPS plans to run experiments to better characterize dust properties? You know, there seems to be large questions around simulating lunar dust for terrestrial experimentation.
So in terms of the CLIPS plans to run experiments, absolutely. I mean, we have, we're trying to, of course, at first do as much as we can on the ground, and there's always this open question, right, of how close are our simulants to the actual regoliths. So we need a lot more, forgive the pun, but ground truth, right? And so that's why these CLIPS missions are so important. We have to get there as soon as we can and get more regoliths. I mean, it's really important. And then also when you have the variants in different regions of the moon, right? And we need to understand all the different areas that we're looking at going and characterize those appropriately and then compare to our simulants. And so we're trying to also bucket between where do we know we need a lot of what I'll call lower to mid quality simulants, and then where do we need the real high fidelity stuff in a lot of our testing even before flight. So it's a lot of a chicken and egg, but yes, the answer is we are planning those experiments. That's why I mentioned, you know, a lot of these experiments are not just technologies, but materials and processes as well, and that we need to get there as early and as often as we can to do these things.
Okay, great. Thank you so much. Okay, so we now have like a 5-minute break. So we'll reconvene here at 12 o'clock. So folks want to grab a cup of coffee or quick something. And so we'll reconvene here at 12 o'clock with our next speaker, which is Michael Johansson, who's going to talk to us about the NASA's dust mitigation strategy and update. And so in the meantime, I know there's been some questions that we didn't get to cover. And so folks are welcome to address some of the questions in the chat box or in the on the Q&A. So thank you very much, and we'll reconvene here in 5 minutes.